Hello, everyone, and welcome to today's webinar, Powering Smarter Mine Planning with MineScape. I'm Jim Srance, and I'm the General Manager and Product Manager of MineScape. And I'm excited to spend the next 45 minutes or so with you exploring how MineScape can help make mine planning smarter, faster, and more efficient. We have a diverse group joining us today, from mine planners and geologists to engineers and operational decision makers. Whether you're focused on geological modeling, mine design, or production scheduling, today's session is designed to highlight practical ways MineScape can support your work. Before we dive in, just a couple of quick notes. First, today's session is being recorded, and we'll make that recording available to you afterward so you can revisit any part of the presentation or share it with colleagues. Second, we'd love to make this interactive, so please feel free to type your questions into the chat at any time. We'll gather them and answer as many as we can during the Q&A time toward the end of the session. Finally, I want to take a moment to thank our Datamine colleagues and partners who helped put this webinar together, and of course, all of you for joining us, especially those connecting from different time zones. We really appreciate you making the time to be here. Here's what we'll be covering today. We'll start with a look at some of the big industry challenges, why precision, flexibility, and integration are becoming critical in mine planning. From there, I'll give you a quick overview of MineScape, showing how it supports both coal and ore stratigraphic deposits across the entire planning workflow. We'll then look at the start page and dashboard, two key features that make it easier to get started, stay organized, and keep your projects on track. Next, we'll step back and talk about MineScape as part of a wider ecosystem, how it integrates seamlessly with other data mine solutions and with third-party systems to create a connected planning environment. Once we've set the stage, we'll dive into MineScape's core capabilities, geological modeling, CAD design, scheduling, and 3D visualization. After that, we'll move into a live demo, where I'll walk you through a typical workflow, starting from the start page, into the dashboard, then into modeling, design, scheduling, and all the while emphasizing visualization. We'll leave time for Q&A, where you can ask about specific challenges or use cases. And finally, we'll wrap up with some closing thoughts and next steps, including how you can explore MineScape further in your own operation. With that context in mind, let's take a closer look at what MineScape brings to the table. Before we dive into MineScape itself, let's take a moment to set the stage with some of the challenges we see across the mining industry today. First, deposits are becoming increasingly complex. Whether it's stratified coal seams or stratified non-metallic deposits, the geology is rarely straightforward. Capturing that complexity accurately is critical to building reliable mine plans. Second, there's growing pressure on productivity and costs. Operations are being asked to deliver more with fewer resources, and that puts immense strain on planning teams. Errors or inefficiencies in the plan can cascade into very costly outcomes on the ground. Third, regulation and compliance are tightening. Mines are held to higher standards on safety, environmental impact, and community expectations. That means plans must be not only technically sound, but also compliant and transparent. And of course, the push for digital transformation is reshaping the industry. Data no longer sits in silos. It needs to flow across departments, disciplines, and even external partners. That requires software solutions that are integrated, flexible, and able to adapt to different environments. So, when we talk about the need for precision, flexibility, and integration, these aren't just buzzwords. They are the practical requirements of modern mining. And unfortunately, many traditional planning workflows still rely on disconnected software or manual processes. That leads to lost time, duplicated effort, and inconsistent data, challenges every one of us has seen firsthand. This is exactly the gap that MineScape is designed to fill, providing a connected, precise, and flexible planning environment that meets these modern challenges head-on. MineScape is an integrated, connected environment. Think of MineScape as an ecosystem like a natural energy pyramid. At the base, we have the producers, the raw data sources. Just as plants capture sunlight and fuel life, in MineScape, the energy comes from drill hole logs, assays, geological surveys, lidar scans, point clouds, and operational data. These inputs form the foundation, feeding the entire ecosystem with information. Moving up, we come to the primary consumers, the geologists and model builders. They consume the raw data and transform it into geological models, block models, and resource interpretations. They give meaning and structure, but just as in nature, some of the raw detail is filtered out. Next are the secondary consumers, the engineers and planners. They feed on what is provided by the primary consumers. They use those models to design pits, define mining blocks, plan waste dumps, and create schedules. They optimize both short-term operations and life-of-mine strategies, converting models into actionable, strategic mine plans. At the top are the tertiary consumers, management and operations teams. At the top of the pyramid, they don't deal with raw data directly. Instead, they rely on reports, forecasts, compliance outputs, and KPIs. Mindscape delivers these insights in a clear, high-level form that guides strategic decisions, investments, and operational performance. Now, just as energy is lost at each of the ecosystem hierarchy levels, data richness decreases as it moves up the pyramid. Raw geological detail is simplified into models, then designs and schedules, and ultimately executive dashboards. But here's the difference. Mindscape ensures that at each level, the right level of abstraction is delivered. No one is overwhelmed and nothing is disconnected. And this is where Mindscape truly stands apart. It's not just one product, it's multiple products, multiple applications, all seamlessly integrated, all contained in a single environment. A complete ecosystem where geology, mine design, scheduling, and reporting live together in harmony. Information flows naturally between stages, ensuring consistency, efficiency, and a single source of truth for the entire mining operation. Data simplifies as it flows, but Mindscape, through its integrated ecosystem, keeps everything connected in one environment, ensuring the whole mining operation works as one. A connected environment where data flows smoothly, teams collaborate effectively, and decisions are made with full confidence. It's about making mine planning smarter, faster, and more integrated. Before I go into a live demo, I think it's important to emphasize how Mindscape is structured. Mindscape is built for teamwork. In this slide, I'll show how multiple users can work on the same projects and design files at the same time, safely and without file conflicts. On the left, we have our database and common shared files. In the center is the server, which stores our Mindscape projects. Think of this as the single source of truth. Projects are saved once, centrally, not copied to everyone's PC. The key piece is the design file server. It runs once on the project server and also on each local machine. Its job is to coordinate access to design files and their layered content, similar to how AutoCAD organizes layers. When multiple users open the same design file, the design file server synchronizes changes and prevents corruption or accidental overwrites. On the right, you see the local machines. They don't pass files back and forth by email or network copies. Instead, they request and share data through the design file server, which ensures everyone sees consistent, up-to-date layers and elements. This architecture lets us support true multi-user editing of projects and design files, maintain data integrity and performance, and eliminate file duplication and version mismatch hell. So, in short, central projects, coordinated design files, and synchronized local access, that's how Mindscape enables safe, simultaneous collaboration. Question: how is this different from simple file shares? Answer: file shares don't coordinate edits. The design file server manages locks and synchronization at the design layer level to prevent conflicts. Question: do users need to check files in or out? Answer: no. There is no manual, check in or check out. The server handles synchronization automatically. Question: what if the network is slow? Answer: the design file server optimizes what's transferred, only what's needed, reducing bandwidth and improving responsiveness. Let's begin on the Mindscape start page. The first thing you'll notice are the products available in Mindscape. You'll also notice Mindscape projects are displayed, so you can quickly get into a project. The start page shows the recently used projects, so if you're working across multiple sites or projects, you can jump straight back in without searching. You also have quick links to some of the most used tools, which makes setup almost effortless. From here, let's move into the dashboard. Now, this is where Mindscape really starts to feel personal. The dashboard is fully configurable. Each widget can be arranged to fit the way you work, whether that's monitoring geological data, tracking engineering tasks, or reviewing scheduling progress. For example, you can pin a widget that shows current production data, another that tracks upcoming tasks, and even a live 3D viewer that updates as new designs are saved. The idea is that as soon as you open Mindscape, you're seeing the most important information for your role all in one place. There are also 3 other tabs that give you access to news, videos, and library. Another key benefit is continuity. The system is always up to date, thanks to continuous updates delivered in the background. There's no downtime, no long installation windows. You simply log in and know you're running the latest version with the newest features. Now, let's dive into RapidCAD. This is the heart of interactive design inside Mindscape and where speed and precision meet. You'll notice a new drawing workspace. Notice how the environment feels like a modern CAD platform, with ribbons and icons, and everything is tailored for mining workflows. If you create a polygon to define a boundary, the snapping tools make it simple to align features, and I can reshape geometry by just sticky snapping to vertices. If you want to create polygons or line strings for a lease limit or a pit outline, you can do that quickly and cleanly. This functionality is available at the mouse level, minimizing moving to and from the ribbon. It's all about being efficient. RapidCAD also gives me advanced geometry tools. For example, you can offset haul roads, create parallel alignments, or automatically clean up overlaps and intersections. These small efficiencies really add up when you're working on detailed designs. The real advantage here is integration. Every CAD object created isn't just a line or polygon, it's linked directly into the geological and engineering infrastructure. That means you can instantly use this design for surface modeling, mining blocks, or scheduling without exporting or redrawing. And it's not limited to 2D. With just a couple of clicks, you can drape a line over topography or extrude a polygon into a 3D solid. This gives instant spatial context and ensures designs are geologically accurate. Of course, all this functionality is also available at the ribbon level. So, RapidCAD isn't just about drawing faster, it's about designing smarter with mining intelligence built into every step and seamless integration across the rest of Mindscape. Now, let's turn to geology, where Mindscape has some of its most powerful capabilities. We'll start with StratModel. This is the engine for building stratigraphic models directly from borehole data imported into Mindscape, or borehole data accessed directly from our geological database. On screen, you'll notice that the boreholes are displayed, and with a few clicks, you can visualize where the coal intervals are intersected, lithological layers, and marker horizons. What makes StratModel so effective is its flexibility. You can apply rules for seam splitting, handle complex faulting, and dynamically update the model as new drilling data comes in, all within the StratModel Manager. It's not just a one-off model, it evolves as your data grows. Watch as the system generates a 3D stratigraphic model that captures the structure and thickness of each seam. Building a stratigraphic model within Mindscape is very efficient. Mindscape has many interrogation tools available, as well as a robust quality modeling system. You'll notice on the ribbon the tools available. All of the borehole data and quality information can be stored in the Geology database, or GDB. This ensures consistency and validation across the entire project. For example, if you add a new borehole or adjust seam correlations, GDB keeps everything aligned so the model and data are always in sync. That means geologists, engineers, and schedulers are all working from the same trusted data set. Another major advantage is interoperability. Many sites already have legacy data, particularly in MinEx. Mindscape makes it easy to import those data sets. Let's walk through that. Here I'll load in a MinEx model. Notice how seamlessly it transfers into Mindscape. The lithology, seams, and attributes are all preserved. That means if you've invested years building MinX projects, you don't have to start over. You can bring that history forward into Mindscape and immediately take advantage of the new tools and workflows. Once the data is in, you can do much more, such as running reserve calculations, linking directly into pit optimization, or driving surface and underground designs. Geology is not isolated here. It's the foundation for every stage of mine planning. So, with StratModel for flexible modeling, GDB for structured data management, and MinX import for continuity, Mindscape gives you a geology workflow that is powerful, connected, and future-proof. Let's look at Pit Optimization Pro. The goal here is to take the generated stratigraphic geological models and economic inputs and generate multiple economic pit limits or pit shells. Within the form, you'll see how the basic parameters such as slope angles, mining costs, processing costs, and commodity prices are easily defined. These inputs drive the optimization. With one click, Pit Optimization Pro calculates pit shells. The system generates multiple scenarios, each representing a different revenue factor. You can quickly compare shells and see which provides the best balance of value and practicality. The results are fully interactive. You can visualize the economic pit limit in 3D, evaluate pushbacks, and access the outputs directly into mine design or scheduling. This takes what used to be a time-consuming process and makes it fast and repeatable. In short, Pit Optimization Pro lets planners test economic sensitivities, validate strategies, and move confidently into detailed engineering. Now, let's look at MineScape OpenCut. This application is designed specifically for mining engineers who are responsible for planning and developing open-cut mines. The engineers need tools that not only create safe and efficient designs, but also streamline the planning process for both short-term and long-term operations. MineScape OpenCut is a comprehensive software tool that combines advanced 3D CAD with rapid design features. This means engineers can build accurate three-dimensional mine designs quickly and efficiently. The rapid design tools let you move from concept to detailed design much faster than traditional methods, which is crucial when schedules are tight. One of the standout features is automated 3D operational planning. With just a few inputs, the system can generate complete 3D operational plans, everything from pit shells and strip designs through to detailed mining blocks. Instead of manually piecing these together, MineScape automates the process, while still giving you full control to refine and adjust. As you generate these designs, MineScape OpenCut automatically stores metadata for each object. That means each block or design carries its own reserve information, tons, grade, and material type. All of that data is embedded directly into the model, making it easy to pull into scheduling and reporting later without rework. On top of that, MineScape OpenCut comes with specialized planning tools for key engineering tasks. You can design and manage drill and blast patterns, lay out and optimize haulage roads, and plan reclamation surfaces as part of the mine's life cycle. And with watershed analysis, you can model how water flows across the pit, supporting both operational efficiency and environmental compliance. What this all adds up to is efficiency in design. By combining advanced 3D CAD with automation, MineScape helps you create reliable designs faster, while reducing errors and inconsistencies. And it's not just about speed. It's about comprehensive planning. With automated 3D operational plans, metadata storage for reserves, and specialized planning tools, you have everything needed for both tactical short-term plans and long-term strategic mine development. Ultimately, MineScape OpenCut gives mining engineers the confidence to make informed, effective decisions for mine development, backed by integrated data, smart automation, and practical design tools all in one place. Now, let's take a look at the short-range planning tools in MineScape OpenCut. These tools are designed specifically for mine planning engineers who need to plan and design cuts, fills, and ramps to be constructed in the short to medium term. They provide a structured workflow that helps you move quickly from concept to completed design while maintaining precision and consistency. The SRP toolset includes a powerful collection of functions for both design and volume calculations. You begin by setting up a plan. Once you define it, the tools automatically apply consistent naming conventions across layers, surfaces, and outputs. That means everything you generate is well organized and easy to manage later. As you step through the workflow, you'll see how SRP guides you sequentially through the process. First, you create detailed excavation plans for cut areas. Next, you move into dump plans, which are handled step by step to ensure balance and accuracy. Finally, you design ramps and benches, and the tools automatically check for gradients and smooth connections to existing surfaces. Because the SRP tools support front-end setup, you can do much of the preparation work up front. That means when you get into detailed design, the process is faster and more efficient. Every design element, cuts, dumps, ramps, can be converted into DTM meshes, and you can merge new structures into existing surfaces without hassle. That integration is essential when plans are updated frequently in short-range timeframes. One of the key strengths of SRP is how it handles output and communication. Once a design is committed, you can generate results in multiple formats: CSV files, spreadsheets, graphical summary tables, and even plan-based callouts directly inside CAD. These callouts visually display plan details on the drawing itself. In short, the short-range planning tools provide everything needed to efficiently develop detailed short-term plans, a structured workflow that accelerates design, accurate volume calculations built directly into the process, and clear, flexible outputs that enhance communication across the project team. This makes SRP an essential part of MineScape OpenCut, bridging the gap between high-level planning and daily operational execution. Next, let's take a look at mining and dump blocks in MineScape. These tools are designed for mining engineers and planning professionals who are responsible for building logical mining units that feed directly into mine planning and scheduling. The goal here is to simplify the process of creating, managing, and using blocks so they're immediately ready for scheduling and execution. Let's start with mining blocks. This tool gives you the ability to generate mining blocks from a single bench, multiple benches, or even an entire pit. For flexibility, it includes scenario management, so you can build different block designs and compare them side by side. One of the most powerful features is the integration with MineScape's Rapid Slicer. This lets you split benches quickly into customized blocks. The slicing process is fully interactive, and once complete, the system automatically calculates reserves and volumes for each block. Each block is assigned metadata, tons, grade, and material type, so it carries all the information needed for downstream planning. For single bench mining blocks, this generates a mesh file straight away, ready for use with the cut start option. For multi-bench or pit mining blocks, the Rapid Slicer tool is embedded into the workflow, so you don't need to take extra steps or use external cutting tools. Everything happens inside the application, making it much more efficient. The process is also guided by an interactive Create Mining Blocks form. This form adapts dynamically based on the mining type you choose, whether it's single bench, multi-bench, or full pit, so the workflow is always streamlined and intuitive. Now let's move to the dump blocks. Here you can design logical dump units with the same consistency and control. Each dump block carries its own metadata, including volume, material type, and capacity. Just like mining blocks, these solids are ready for scheduling the moment they're created. And that brings us to integration. Both mining and dump blocks connect directly into the tactical scheduler. That means once blocks are created and reserved, they can be scheduled immediately without extra formatting or conversions. This seamless link reduces errors, saves time, and ensures that designs transition smoothly into executable schedules. In summary, the mining blocks and dump blocks are about efficiency and integration. They streamline the creation of mining units at any scale, automate volume and reserve calculations, store all relevant metadata, and integrate directly with scheduling tools. This gives engineers and planners the ability to build practical, data-rich blocks that move straight into execution, improving both productivity and decision-making across the mine planning process. Single mining blocks can be cut interactively using line string elements, each with an assigned cut slope. As you define your cutting lines, the system dynamically calculates and displays the volume of each block in real time, giving you immediate feedback on your design. These line string elements aren't fixed. You can move or adjust them at any time to refine your cut. When changes are made, the blocks are automatically recut, and their updated volumes are instantly shown on screen. Once you're satisfied with the results, simply end the cut operation, and the final geometry will be written directly to the mesh folder. This ensures your updated mining blocks are stored and ready for downstream processing or reporting. Additionally, these bench blocks can be reserved, allowing you to maintain control over areas that are already accounted for in planning. During this process, the calculated volumes are written to each block as metadata, preserving detailed information for later use in scheduling, reconciliation, or production tracking. Now, let's have a look at Dragline. MineScape Dragline offers a comprehensive CAD-based modeling environment with a user-friendly interface for creating and testing dragline excavation methods directly on pit models. It supports the simulation of various excavation techniques such as cast blasting and production dozing to accurately model pit operations. The application integrates seamlessly with MineScape models, utilizing both simplified design elements and real geology from pit surveys and drilling data. Engineers can define and store customizable operating parameters for different dragline units and assign material characteristics like swell to specific stratigraphic units. Using a cross-sectional approach, the application automates movement processes, displays cut and spoil geometries, and ensures volume conservation. The replay functionality enables full spoiling simulations across multiple sections, creating 3D surfaces for multipass mining, optimizing rehandle strategies, and evaluating pit designs. Design and optimization tools allow engineers to test and refine equipment casting methods and compare productivity across various dragline configurations. Comprehensive reporting features generate detailed reports on prime and rehandled material movements, 3D surfaces for reclamation planning, and fully dimensioned range diagrams. MineScape Dragline enhances pit planning efficiency by reducing the time required for planning and optimization, enabling faster decision-making and better adaptation to changing conditions. It ensures accurate modeling of pit operations through precise data integration and simulation, minimizing errors and boosting confidence in planning outcomes. By streamlining planning processes and optimizing equipment use and material handling strategies, it reduces operational costs and improves project profitability. The application provides powerful tools for mining engineers to evaluate multiple scenarios, test alternative excavation models, and optimize future operations. It also offers comprehensive control and flexibility in defining and refining excavation methods, accommodating a wide range of mining scenarios and operational needs. In this demo, we'll set up a new scenario within MineScape's dragline planning environment. Rather than recreating existing dragline sections, this functionality provides the dragline engineer with the flexibility to test and compare different operating methods efficiently. By creating a new scenario, we ensure that the previously defined setup remains intact while we explore new optimization strategies. The focus of this scenario is to determine the optimal dig and dump angles that will maximize dragline production. MineScape now includes an interactive swing angle calculator, a powerful feature that allows planners to dynamically adjust both dig and dump angles within the 3D environment. As the engineer modifies these parameters, the system instantly recalculates cycle times, swing paths, and productivity outcomes. This real-time feedback gives planning engineers the ability to visualize performance impacts and make informed decisions to improve efficiency. The result is a more agile, data-driven approach to dragline operation planning, helping to achieve the ultimate goal of maximizing productivity while maintaining operational control and precision. Now let's turn to MineScape Drill and Blast, a tool designed for mining engineers and blasting specialists who are responsible for creating and managing drill and blast designs. This application is focused on delivering efficient, precise, and legally compliant blast planning. Let's start by opening a bench surface. From here, you can quickly create a 2D drill pattern in CAD. Notice how the tools allow you to define hole spacing, burden, and alignment interactively. Once the 2D pattern is in place, you can instantly project it into 3D, aligning holes with the actual bench geometry. From here, Mindscape helps manage the details. You can add charging decks, define charging needs, and calculate powder factors. The application even handles detonation delays automatically, but you still have full flexibility to adjust them interactively in CAD. That means you can refine timing sequences hole by hole until you get the exact outcome you want. The application also calculates all the key metrics: powder consumption, charge weights, and detonation timing tables. These are generated into detailed reports that can be used directly in the field or submitted for regulatory compliance. That ensures the blast designs are not only effective but also fully auditable. Another strength of the tool is flexibility. If conditions change, you can quickly adjust patterns, alter charging requirements, or recalculate timing sequences. The system updates volumes and charge totals immediately, giving you confidence that the design is accurate before it goes to the field. For compliance and monitoring, MineScape Drill and Blast generates GPS-compatible reports, so drill positions and charge layouts can be tracked against the actual field conditions. This ensures the plan is executed safely and matches legal standards. By integrating directly with the geological model, survey updates, and the mine plan, the application ensures the blast designs are always aligned with the latest data. This reduces rework, saves design time, and provides precise control over every blast layout. So, to sum up, efficiency and precision come from automated tools that speed up design while maintaining control, and flexibility and compliance are achieved through customizable CAD workflows and comprehensive reporting that meet site-specific and regulatory requirements. MineScape Drill and Blast gives engineers and blasting specialists a complete solution for safe, efficient, and compliant blast planning right from the design phase through to field execution. Next, let's shift focus underground. MineScape provides tools purpose-built for underground coal operations. On the screen, you'll see a boundary layer displayed that defines the underground mining limit. This boundary was generated by referencing the stratigraphic model, analyzing seam thickness, splits, and geological structure, all critical factors for designing underground layouts. Using RapidCAD to lay out a center line, you can generate panels. Whether it's a board and pillar or longwall configuration, the interactive layout tools allow you to set dimensions, spacing, and orientation. The panels are generated instantly and can be adjusted before the design is committed. Here's where it gets even more powerful. Every panel design can be converted into 3D solids. These solids aren't just visual shells, they're fully attributed objects. Reserve information such as tons, grade, and coal quality is written directly into each solid as metadata. That means every object carries its own reserve intelligence. These solids can then be passed directly into the tactical scheduler. So, instead of scheduling abstract blocks, you're scheduling the actual design solids, complete with their reserve data. This creates a seamless connection from underground design to reserving to scheduling, all inside one workflow. The result is a fully integrated underground planning process. Geology informs design, design generates solids, with embedded reserve information, and these solids drive realistic scheduling scenarios. That's how MineScape helps reduce manual effort, improve accuracy, and ensure your underground plans are practical, compliant, and ready for execution. Now let's move into the tactical scheduler. This is where planning becomes execution. The tactical scheduler allows us to take all the work we've done with geology, pit optimization, pit design, mining blocks, and dump blocks, and convert it into a realistic production schedule. Let's start by opening a schedule scenario. Here you can see the interface. On the left, I have my list of available mining blocks and dumps, and on the right is the timeline where I'll build my schedule. The system automatically pulls in block data, tons, grade, location, directly from the geological and engineering database. That means no imports, no manual reconciliation, it's all connected. I'll begin by assigning a sequence of mining blocks to the schedule. Notice how quickly the system builds a period-by-period plan. If I hover over a period, I can instantly see production targets, ore tons, waste tons, strip ratios, and even grade profiles. These KPIs update in real time as I make adjustments. The scheduler isn't just a static tool, it's highly interactive. Let's try a what-if scenario. Suppose commodity prices drop and we need to prioritize higher grade material earlier. I can drag and drop blocks to resequence, and immediately the production charts and stockpile balances update. This kind of flexibility lets planners test multiple strategies in minutes rather than hours or days. Another key feature is integration with dump blocks. As I assign mining blocks, the scheduler simultaneously tracks material destinations. So if I send overburden to a specific dump, the capacity and geometry of that dump update automatically. This makes it easy to ensure that dumps are not just planned, but physically achievable. Visualization is also powerful here. Let me switch to the 3D view. Now you can actually see the mining sequence unfolding across the pit. Period by period, the pit evolves, giving engineers and managers a clear picture of how the mine will progress over time. This visual feedback is incredibly valuable for communicating plans to stakeholders. The tactical scheduler also includes reporting tools. I can export production schedules, equipment demand, or compliance metrics directly to a report or dashboard. That way, decision makers have both the big picture strategy and the detailed numbers they need. And because everything is integrated, geology, engineering, blocks, and scheduling, there's no disconnect. If a block changes or a new survey updates the surface, the schedule can be refreshed in minutes, keeping planning aligned with reality. So, the tactical scheduler gives mine planners the ability to move quickly from design to execution, test alternative scenarios, and build confidence that the plan is both efficient and achievable.